Hi, good morning. So today I'm going to be working out the stoichiometry examples for you in case you need to take a little bit more time to see them. I do want to remind you that stoichiometry is one of the more difficult topics we cover. Please be patient with yourself. Almost everybody has to sort of teach themselves and learn how to do this. It's not easy for anyone. Okay. So the first part of stoichiometry is to make sure that the equation is that you're given is balanced. And so we want to check that by looking for coefficients. And we can see that there is a coefficient of 2 right here on H2O. So since we do already have a coefficient, that means that this is already balanced, which is good news, right? So after it's already balanced, step 2 of stoichiometry is to convert the grams of the known to moles. But in order to do that, we have to already know like what is the known substance. So we want to go through and we want to read this equation again, and we want to figure out what do we already know, as well as what do we want to know? What is the problem asking for? So let's go through and read the equation and see if we can figure out what do we know. So it says determine the mass of water produced by the decomposition of 25 grams NH4NO3. So anything that has a number, that's usually a pretty good indicator that that's probably what we already know. So what we know is that we have 25 grams NH4NO3. And then what we want to know is what the problem is asking for. So in this particular problem, it says determine the mass. So determine the mass or how much. These are all things that are giving you a good hint that that's probably what you're trying to solve for. So mass of water is what we want to know. So what we're looking for is how many grams of H2O. So it's important to already know these things at the beginning of the problem because these are the units that you start with and these are the units you're trying to make. And so that's sort of going to help you to know the flow of what order to do things in. So once we already have established that our equation is balanced, now we are going to go ahead and our step 2 is to convert the grams that we have into moles. So in order to convert something, we always start off by taking what we know and putting it over 1. So we're going to start by putting 25.0 grams NH4NO3. That's going to be put over 1. So our first set of parentheses is always just what we already know. Okay. So our second set of parentheses is where we're going to make our first conversion. So this is going to be step 2. So in step 2, we want to make grams. Step 2, this is going to be grams into moles, right? So what we want to do, always, whatever units we have, which the units are whatever comes after the number. So whatever units we have on the top of our first set of parentheses, they're always going to be put on the bottom of the next set of parentheses so that they will cancel out. So grams NH4NO3 is going to go on the bottom here. And then in step 2, we're making our grams into moles. So that means that moles of NH4NO3 need to go on top. So whenever we convert between grams and moles, we use molar mass. So I need to know what the molar mass of NH4NO3 is. So as we've talked about previously, whenever we find the molar mass, we want to write down the elements that we have in that compound. So the first element we have is nitrogen. Next, we have hydrogen. Then we have nitrogen again, but since it's already written down, I don't have to write it. And finally, oxygen. Now I'm going to figure out how many atoms I have of each of those elements. So nitrogen, this nitrogen has no subscript, so there's only one. But remember, we have another nitrogen over here. So total nitrogens are 2, hydrogens are 4, and oxygen is 3. So those are what we're going to multiply the atomic mass from the periodic table. So you would look up the mass of each of these elements in the periodic table. I happen to know what they are, so we're just going to, in the interest of time, sort of skip looking it up, and I'll just tell you. So nitrogen's mass is 14.01. So 2 times 14.01 is going to be 28.02. Hydrogen has a mass of 1.01. So 4 times 1.01 is going to be 4.04. And then oxygen has a mass of 16. So 3 times 16 is 48. So we're going to go ahead and we're going to add those up. Apparently I can't pull my calculator app up right now. So I'll just do it here. Actually, we can do this the old-fashioned way, right? So 4 plus 2 is 6. Ooh, that was a very bad 6. Try that again. So 4 plus 2 is 6 zeros. So 8 plus 4 is 12, plus 8 is 24. So this is going to give us 80.06 grams is 1 mole. So now what we want to do is this is going to be the conversion factor that we're going to use to fill in the numbers in our parentheses. So look at the number 1 is next to mole. So I'm also going to put the number 1 next to mole up here. 80.06 is next to grams. So 80.06 is going to go down here. So now we can see that we have grams of NH4NO3 on the top and on the bottom, which means that we can go ahead and cancel those units out. Okay, which leaves us with moles of NH4NO3. Remember that the units we're trying to solve for are grams of H2O, so definitely we're not to where we want to be yet. So that means we need to have another set of parentheses. So this is going to be our step 3 from the notes. So step 3 is the mole ratio. So remember that in the mole ratio, we're going to be getting our numbers from the equation, from the balanced equation, right? So we need our coefficients. I'm going to write that here just so you remember. So before we worry about those numbers, those coefficients, though, we always want to do our units first. We do the units first to make sure that we're not reversing and putting the wrong things on the top and the bottom. If you make sure that your units from the last parentheses are canceling out, you will always have things set up correctly. So moles of NH4NO3 needs to go on the bottom. Okay. And then moles of what we're wanting, in this case, which is H2O, is going to go on the top. Remember that in a mole ratio, we always have moles on the top and on the bottom. That's what makes it a mole ratio. And remember that these numbers that we fill in come from our balanced equation. So H2O, we're going to find that in our equation, and it's right here. And that's the one that does have a coefficient, right, that let us know this equation was balanced. So we're going to go ahead and we're going to put this coefficient 2 right here into our equation. So the other substance we're looking for is NH4NO3, which is right here in our equation. And you can see that it doesn't have a coefficient. And so we're going to put in a 1. So we're going to put a 1 right here. Okay. So now, once again, we're ready to cancel some units. Moles NH4NO3 we have on the top and on the bottom. So I'm going to go ahead and cancel those guys out. And that's going to leave me with moles of water, which is getting really close, right? We want grams of water. So we have one last set of parentheses. This is our step 4. So step 4, where we're going to have the moles and convert that back to grams so that we can find our answer. So once again, we always start by putting the units from the previous set of parentheses on the bottom. So moles of H2O is going to go on the bottom. And on the top is going to be grams of H2O because that's what we're trying to solve for, right? So we are going to go ahead and we have to find the molar mass again. So, but this time we're doing H2O. So we have hydrogen and we have oxygen. So we can see that hydrogen has a subscript of 2, so we're going to put that there. And oxygen doesn't have a subscript, so there's only 1. So 2 times the mass of hydrogen from the periodic table is 1.01. So that's going to be 2.02. And the mass of oxygen from the periodic table is 16.00. So we're going to add those up to get 18.02 grams is equal to 1 mole. So next to grams, the number that's next to grams is 18.02. So I'm going to fill that in there. And the number that's next to moles is 1. So I'm going to fill that in there. Now, once again, I can cancel my moles of H2O because I have them on the top and on the bottom. I'm left with grams of H2O, which is exactly the units that we want to have. So once we have the units we want to have, we are ready to do our calculation. So we're going to go ahead and simplify this. And so what we're going to do is we're going to multiply all of the numbers that are on the top times one another. So this would be 25.0 times 1 times 2 times 18.02. And this is going to be divided by 1 times 80.06 times 1 times 1. So this would simplify to, so 25 times 2 times 18.02 is 901 divided by 80.06 because 1 times 80.06 times 1 times 1 is just 80.06. So 901 divided by 80.06 gives me 11.25. So this is going to be 11.25. But remember that it's not correct without a unit, which in this case is grams, and a substance, which in this case is H2O. So they're also located right here. Those are the ones that are not canceled out up here. So this right here, my friends, is our answer. So let me, yay, final answer. All right, so that is example 1. I'm going to go ahead and move right on to example 2 to try to make our video not super duper long. So here's our second example. It's a lot like the first one. In any case, it says 2Na-N3 makes 2Na plus 3N2. And this is the decomposition of sodium azide. It causes airbags to inflate. This really is what's happening in your car if you get in an accident. That N2 gas that's produced is what blows up the airbag. And we want to know what the mass of that is produced if we have 100 grams of Na-N3. So, of course, our first question, is it balanced? So, already balanced. That's a little bit easier to see with this one because all of them have coefficients, right? But that's how we knew it was already balanced. So once we know that it's already balanced, we want to establish and figure out what we know and what we want to know. So what do we know and what do we want to know? So looking back at our equation, let's see, it says we have 100 grams of Na-N3. So the thing that already has a quantity to begin with is usually what you already know. So what we already know is that we're starting with 100.0 grams of Na-N3. So what we want to know It says decomposition of sodium azide causes airbags to inflate. What mass of N2? So mass of N2 is what it's asking for. So what we want to know is how many grams of N2. So now that we've established that, we know where we're starting and we know when we're finished. Now we're going to start setting up our parentheses in order to make the conversion to get from here to here. So we always start by taking what we know and putting it over 1. So in this case, that would be 100.0 grams of NaN3. We're going to put that over 1. So remember that this is always what we know goes here. So the second set of parentheses is when we convert the grams of what we know into moles. So in order to do that, we need to cancel out grams. So we have to make sure that grams of NaN3 goes on the bottom. And in turn, moles of NaN3 goes on the top. So whenever we're converting between grams and moles, that's going to be using a molar mass. So the elements we have involved are sodium, which is Na, and nitrogen, which is plain N. So we have only one sodium because it doesn't have a subscript, so we're going to put 1. And we have 3 nitrogens because the subscript is 3, so we're going to put a 3 there. Then we're going to multiply those by their atomic mass from the periodic table. So the mass of sodium from the periodic table is 22.99. So 1 times 22.99 is just 22.99. And nitrogen is 14.01. So 3 times 14.01 is 42.03. So we're going to add those up. And so this is going to get 65.02 grams is equal to 1 mole. So we're going to fill in. We know that the 1 is next to the mole. So we're going to put a 1 next to mole. And then 65.02 is next to grams. So we're going to put 65.02 next to grams. And now I can cancel out my grams of NaN3 because I have it on the top and on the bottom. So at this point, I have moles of NaN3. Now, remember that I want to get to grams of N2, so that means I need to change substance. So the whole reason we made moles here is so we can use a mole ratio because that's the part of the equation that allows us to change the substance we're talking about. So we want to cancel out the moles of NaN3, so we put that on the bottom. And we want to change our substance to N2, so we're going to put moles of N2 on the top. So remember that in our mole ratio, where we get the numbers to fill things in, we're not doing atomic mass here. What we're doing is we're looking at the balanced equation and finding the coefficients. So the coefficient for N2 is right here in the equation. The coefficient is 3. So I'm going to put a 3 right here. That's where that 3 came from, is our balanced equation. So NaN3, we're going to find that in our balanced equation, and it is right here. And so it has a coefficient of 2. So that's what we're going to fill in right here is that 2. So once we've done that, we can go ahead and we can cancel out our units. We have moles of NaN3 on the top here and on the bottom here, so we can make them cancel. Now we have moles of N2, which is very close, but not quite there for grams of N2. So the last set of parentheses, we have to change those moles back to grams. So we're going to put moles of N2 on the bottom, so it will cancel. And grams of N2 on the top, because that's what we're trying to make. Now, whenever we convert between moles and grams, we're always using a molar mass. So we're just going to find the molar mass of N2. So nitrogen, we have 2 of them. So 2 times 14.01 is equal to 28.02 grams equals 1 mole. So next to grams, down here we have 28.02 is next to grams. So that's what's going to go next to grams up here in our parentheses also. And then next to moles, we have a 1. So we're going to put 1 next to moles here. So you'll notice that we can cancel out moles of N2. We have the same thing on the top and on the bottom. So we're going to go ahead and cancel those guys out. That leaves us with grams of N2 here on the bottom, which is exactly what we're looking for, which means that it's time to put an equal sign and to start simplifying this equation. So remember that we always take and we multiply all of the top ones times all the other top ones. So this is going to be 100.0 times 1 times 3 times 28.02 divided by 1 times 65.02 times 2 times 1. So 100 times 3 times 28.02 is 8,406. And 65.02 times 2 is 130.4. So 8406 divided by 130.4 is equal to 64.46. So this is going to equal 64.46. But remember that we must always have a unit. So our unit in this case is grams and a substance. And so our substance in this case is N2. So that, my friends, is our final answer. So I hope this has helped to clear things up a little bit for you guys. And if not, please contact me and I will be happy to help you individually. So have a great day. Bye.